Almost all of us have a microwave oven at home. This film shows how it is possible, under certain conditions, to make this device work in a particular way to generate cold. This is the microwave oven's hidden side. You might wonder why certain electric plugs can only be plugged in one way round. It is simply a protective system, often referred to as a polarizing device, used to take the power system's polarity into account. This polarizing device can be found in various forms, such as, for example, on the power supply of a portable computer. It is then impossible to connect the electric plug the wrong way round. If we look at the electric wiring of a wall socket, we can see that the power system's polarity is shown by two different colored wires. The power system thus seems to be polarized. We modified a power cord to observe the electrical voltage on an oscilloscope and confirm our hypothesis. Let's connect the two different colored wires to the input connector of an oscilloscope. The power plug doesn't have a polarizing device. It can thus be connected either way round. The supply voltage has a sinusoidal form. Its amplitude rises to a maximum and then falls to a minimum. Let's now connect the plug the other way round. This demonstrates the importance of having an electric plug without a polarizing device that can be connected either way round. The voltage is reversed and this time decreases first to a minimum value. We have just ascertained that the mains voltage is polarized. The question is to know whether the way certain devices work is changed when an electric plug without a polarizing device is connected one way round or the other. For example, let's observe an incandescent bulb. The way it works remains identical when it is connected one way round or the other. Let's now connect a light meter to a spectral analyzer to observe the luminous flux developed by the lamp. When connected this way round, the frequency response of the light waves contains few harmonies, and the light has a high spectral purity. If we reverse the power system polarity, the frequency response contains more harmonics. The light is polarized, which some people perceive as a flickering effect that can be easily eliminated through the use of a polarizing filter available on certain spectacle lenses. Let's now observe how an orange squeezer works. The electric plug doesn't have a polarizing device. The polarity of the mains supply will have no effect on its operation. Let's mark one of the plug's phases with a colored sticker. Then let's connect it to the corresponding mark. Then let us cut an orange carefully so that we can squeeze it. When the plug is connected in the previously defined direction, we can see that the orange squeezer turns counterclockwise. Let's reverse the polarity by connecting the electric plug the other way round and see the way the orange squeezer works. It now turns clockwise. We can see that the orange squeezer's direction of rotation has no effect on the way it works. An electric plug with a polarizing device is not necessary. We can now wonder what would happen if the plug of a microwave oven were connected the other way round. Unfortunately, this experiment can't be done because the power cord has a polarizing device. It is, however, simple enough to bypass the polarizing device's protection. You just need to make an adapter cord, allowing the two wires of the mains power supply to be reversed. To do this, let's use a socket and an electric plug simply bought in a DIY store. We also need some electrical wire about 10 centimeters long. Let's wire one end of the wire to the socket, without forgetting to connect the two colored wires and the ground wire. With this simple adapter, we'll be able to connect the microwave oven supply the other way round, and thereby bypass the polarizing device's polarity reversal protection. Let's then use our adapter. Simply connect the microwave oven's plug to one end of the wire and the other end to a power socket. Let's fill a glass with 100 milliliters of distilled water. The liquid is at room temperature, that is 20.3 degrees Celsius. Let's set the oven's power selector to the halfway mark. This corresponds to a power of 440 watts. Let's select an operating time of 10 seconds. Apparently, the oven seems to work normally. The control electronics seems to adapt to the power supply polarity reversal. Let's finally observe the liquid's behavior for this particular way of operation. It can be seen that the temperature has decreased by 10 degrees Celsius. Reversing the polarity of the microwave's power supply has allowed a liquid to be cooled. If 10 seconds of operation at 440 watts has decreased the temperature by 10 degrees Celsius, what will be the effect of 10 more seconds of operation at maximal power? The results are spectacular. The 100 milliliters of liquid have been turned into ice. As the calorific inertia of distilled water is fairly low, let's use a Fresnel fluid with a high thermal hysteresis cycle. This fluid has a relatively high calorific inertia, which avoids it turning into ice too quickly. The container used will be simply a soup plate, the composition of which is particularly well suited to the oven's waves. The liquid's measured temperature is about 19 degrees Celsius. This time, let's set a time of 2 minutes at maximal power, the theoretical time needed to obtain the drop in the liquid's temperature. As for the distilled water, the high hysteresis cycle Fresnel fluid has been completely turned into ice. We can see that reversing the polarity of the power supplied to the microwave has generated cold. The big question is how the calories extracted from the liquid were transformed. In other words, what became of the liquid's heat when the temperature fell from 20 to 0 degrees Celsius? To answer this question, let's remove the adapter and reconnect the oven again in its normal way of operating. Let's place a glass of water in the oven and observe the direction of movement of the electrical power supplied to the microwave using a power meter. The needle moves towards the oven since the device consumes power. This is completely normal. Let's reverse the polarity again by means of the adapter. Let's place a glass of water in the oven again and observe the direction of movement on the power meter. The needle changes direction, meaning that the microwave oven is supplying electrical power and is working as an energy generator. The liquid's heat has been turned into electricity. So, is it possible to recover this power produced by the microwave oven? We connected 3 lamps at the output of the power meter when the oven is working in polarity reversal mode. Let's place our mixture of hysteresis cycle Fresnel liquid in the oven again. Let's start our experiment with a power of 250 watts. As soon as the oven starts, the first lamp comes on. The liquid loses its heat, which is turned into electrical power. If the selector is set to 440 watts, the power increases and the second lamp comes on. With 600 watts, the power is enough to light all 3 lamps. The Fresnel fluid has given up all its heat to supply our light bulbs and has been turned into ice. Mankind has to find new sources of energy to meet its needs. We now know that the water of our rivers, when used with gigantic microwave ovens, can provide us with this clean, inexhaustible source of renewable energy.